Hi everyone, my name is Miss Ho, or you can call me Teacher Zyen. So this is the second video in my SPM 2020 series, and what we'll be doing in this video is we're going to be focusing on how to answer paper 3, question 2. In my first video, I have already covered how to answer paper 3, section A, question 1. So continuing from where we left off. For the purposes of this video, I will be using the SPM 2019 actual past year paper as the example. So if you have this, please grab a copy of it, even if you've already done it, just so that you can follow the video. Now, please remember that the tips and tricks that I'm going to be sharing in this video on how to answer the questions can be used in all SPM Physics Paper 3, whether it's another past year paper, trial paper, or even a model paper, if you will. Right? So I found another app which I can use. Hopefully this will give me a lot less problems than the app I used in the first video. Okay? I will now be scrolling down to question 2 because we've already done question 1 in the first video. If you haven't seen it, please check out the link in the comments below. Where are we? Okay, here we go. So as with the first video, I'm not going to be focusing on the answers per se, but we're going to be focusing on how to get the answers. And I know this is very important for a lot of you because some of you don't know how to get the answers to the question. So like I mentioned in my first video, the SPM Physics Paper 3 is the easiest paper among the 3 papers in this subject. And the good thing about this paper is that even if you don't remember everything about physics, even if your physics concepts and the knowledge that you have is not very strong, you actually can still score quite high marks because it's a very technical paper. What you do need to know, of course, is have some knowledge about science and how to do experiments. But if you have all that, there should be no problems for you to get quite high marks. Like, for example, in question 2 out of 12 marks, even if you don't know even if your physics knowledge is not very strong, you can actually still quite easily score 8 marks and above. So, without further ado, let's get started. So looking at SPM 2019 paper, let's look at question 2. Now, all physics paper 3 that's based on this particular format, the question 2 always gives you a graph. So you can see that there's a question here, and it told you the experiment results are shown in a graph on page 12. So let's just scroll to page 12, and you find that, yes, there's a graph that's given. So to answer question 2, you need to refer to this graph. Make sure you read the question carefully to check out what information is given here. Right? So the questions, of course, may differ from paper to paper, but it's always centered around the graph. So for example, this particular question asks you what happens to theta as t increases. Of course, just look at the graph and you should be able to get the answer. See, as t increases, theta increases. Oops. Let's go back here. Okay, and that's what you write. So for the sake of completion, I'm just going to scribble the answer here. Increases. Okay, let's do that again because that was not very clear. So although I say I'm not focusing on the answers in this video, I'm just going to fill in the answers here so that it feels a little bit more complete. Okay. Now, let's take a look at another kind of question. Now let's look at the following question here. So it says, okay, determine the initial temperature of liquid theta 1 and show on the graph. Now this is very important. I'm just going to put a different color here as a highlight. Let's use purple, show on the graph. Please remember that every time you've got to get an answer from the graph, you must show. Typically, the question would tell you to show on the graph. Even if it doesn't, make it a habit to show on the graph. Now, what we mean by show on the graph, how you determine value, it depends on the question. For example, in this case, you want to determine the initial temperature, right? So when you look at this graph, you're like, okay, this is a hanging graph. Now, although it's a hanging graph here, it doesn't mean you can draw hanging graphs. This is a hanging graph so that you can show the examiner that you know how to get the answer, right? So how do you get the initial temperature? Obviously, you've got to extrapolate this graph so that it touches the y-axis. So I'm going to use this color here. Okay, using your ruler. Now, of course, I don't have a ruler because I am using my pen tablet. But using your ruler, what you need to do is you need to extend this with a straight line until you get the intersection of the y-axis. And from here, you get the answer. Just by drawing this line, you already get 1 mark. Reading the value correctly then enables you to get the other mark. So when you write the answer here, say for example, this is 20, what was the value just now? Sorry, I didn't check. So let's say this value is approximately, say, 27 degrees Celsius. So make sure that when you write the answer out, you also write the unit. If you just wrote the value in here, you will not get full marks. You must write the answer with unit. So 2 marks here. The 2 marks allocation here is 1 for showing on the graph, that's the extrapolation of the line on the graph, and the second mark is the value with unit. And that's how the marks allocation work. Next, calculate the gradient of the graph, theta against t. And like in the previous question, show on the graph. What does it mean when you show on a graph? So to show on a graph means you need to draw the gradient triangle. So the 3 marks allocated here is 1 mark for the gradient triangle, 1 mark for the calculation, which means you need to show the values of coordinates that you are you obtained and you're calculating, and 1 more mark for the final answer, which is the value with the unit. So a lot of students say, huh? Since when gradients have units? Well, if you've gotten to this stage at this point, you've got to ask yourself, have you been paying attention in class? Because any teacher who's covered this has to let you know that the gradient of the graph in paper 3 must be complete with units. So let's talk about a gradient triangle first. Let's backtrack to the graph. When you want to obtain the values to calculate the gradient, please remember that you must get the values that are as far away from each other as possible. Or in other words, get a triangle that is as large as possible. So I'm just going to zoom out a little bit so that we can see the whole graph. Okay. And don't aim for a small triangle. I know a lot of students, they feel like, oh, it's so troublesome to draw such a big triangle. So you know what they do? They go and get one tiny little triangle here. They're like, okay, you know what, teacher, I think this is enough. No, it is not enough. It's far from being anywhere suitable. Because if you draw such a small triangle, you're probably not going to get any marks at all. So please remember this rule that for physics, as big as possible, all right? Ideally, get the 2 points that are at the beginning and at the end. If you find that the end point is kind of in an awkward position, that you're like, okay, I can't really get a good coordinate at the last point, then find the next best point that is still quite high. So say for example, in this particular graph, we're going to go with this point rather than this point. Click on that, get this point, because this point is a little bit awkward, right? You can start from the point which you've extrapolated, and that's fine, because it is still part of the graph. If you don't feel confident with that and you want to start at the point that's given in the graph, that's fine too. Okay. So I'm going to go with the point of extrapolated. Let me just erase that because there's something extra there. Okay, so please remember that when you draw your gradient triangle, you need to draw the triangle using dotted lines and with a ruler. Now, of course, I'm not using a ruler at the moment because I'm using this app, and for some reason it doesn't have a line tool. But for you guys, no excuse, right? Because you're doing it on pen and paper. You must have your ruler with you. So draw the gradient triangle with dotted lines, and this is fine. If you draw it like this, it's already good enough. Okay. If you want to really make sure that the examiner knows this is a gradient triangle, you can also add this, the change in y over change in x, because that's how we calculate gradient. So when you then put the values in your calculation, please make sure you take the coordinates correctly. So let's say, for example, in this case, this is 95 and 620. 620 and 95. And this is, of course, 0.27. So make sure that you put the values in correctly. So let's go back to, so let's calculate the gradient then. So if you remember the gradient calculation, it is y2 minus y1 over x2 minus x1. Of course, just put in the values that you get from your own gradient triangle. So in my case, it was 95 minus 27 over 620 minus 0. So punching that into the calculator, you've got, let's say we've got about 0.1097. So don't worry if your number is not exactly the same as your friends, because there is actually an acceptable range of numbers, because it depends, of course, on the coordinates that you obtain from your own graph. As long as you have read the graph correctly and you put in the values correctly, punched it into the calculator correctly, you should be fine. But very importantly, please remember that you must put in your units. So if you're wondering, oh my God, what are units for gradient? Units for gradient, of course, depends on the graph, which means that it does differ from question to question. How do we get the unit? Look at the unit for the y-axis and look at the unit for the x-axis. So for example, in this particular graph, the unit for the y-axis is degrees Celsius and the unit for the x-axis is seconds. So you can think of it as this is actually degrees Celsius divided by seconds. And that's your unit, degrees Celsius per second. So these are some of the examples of show on the graph, which means that, like I said, you must show on the graph. Another example of show on the graph would be to look up values. So it's not in this question, but an example of this could be, they'll give you, okay, if t is, let's say, 20 seconds, how much is the value of theta? If you had to look up the value on the graph to obtain the value, then you must draw the dotted lookup lines. Okay? So remember that when you are looking up values or you're referring to the graph as a guideline, the lines must be dotted. If it's an extension, for example, this is an extension, it's actually part of the graph, then you draw solid lines. Very important. So these must be dotted. Let's use yellow for this. Okay. Dotted because they're not part of the graph, they're guidelines. But if the line is actually part of the graph, then they're solid lines. Okay, so now we've come to the next question, and typically the next question always requires you to use the gradient in some way if you have to calculate, something for a new formula over here. So if you read the question carefully, it does say using the value of k into A3. K into A3 is what? The gradient, right? So you need to use the gradient that you calculated into A3 within this question. Now, if you look at the formula, you're like, but where does K fit in? Some questions give you, the K symbol in the formula itself, and some don't. Now, if they don't, how do you solve the question? So this is what you do. You've got to figure out the symbols that are used in K that can be used to replace what's in this formula. What do I mean by this? Now, if you look at K, what is it? What is it actually? K is y over x. Our y is theta, degrees Celsius, and time in seconds. So I'm going to write that over here. Let's use this color. K is actually theta over time, correct? Theta over t. Now, if you look, like, okay, there is a theta here and there's a t here. What you do in order to solve this question is to rewrite this formula so that you can replace K into this formula. Some of you may already like, oh, okay, I see exactly how this works. Especially for those of you who are very good at maths. For those of you who can't see it, then this is what you can do. You need to rewrite this formula and make theta over t as the subject. So I'm going to do this on the side here so that you can see how it works. So I'm going to do this step by step for those who don't quite know how to figure it out. So we've got pt over m theta. So what we're going to do is we're going to bring theta over t to the left side as the subject. I'll do this step by step so that you can follow me, right? So I'm going to bring this up first. Cm theta equals to pt. We're going to bring t down and bring cm here. So we've got theta over t equals p over cm, right? Okay, so now you can see, okay, my left side is now the same as k. So what you're going to do now is you're going to replace, let's do it on this side. We're going to replace theta over t with k, and we're going to keep p and cm over here. Okay, k is 0.1097, so I'm going to substitute that in right now. P, if you're looking, oh, where do I get P from, and I've got C and I've got M. Okay, where do you get these values from? So if you look at the top of the question, you've got P is 100 watts here and T is 200 grams. So which means that you can substitute the values of P equals 100 watts, and mass is 200 grams, and you substitute it right into the formula here. But please remember that they want in SI units. So you've got to put M as 0.2 kilograms. So we're going to substitute that right in here as 100 over C and 0.2. We're going to rewrite because we need to calculate C, right? So C is 100 over 0.1097 over 0.2. Punch it into your calculator. And in my case, I've got 4557.885. Please remember to always write up to 2 or 3 decimal places. You need to write it in SI unit. If you've forgotten, well, you got to try to recall. Specific heat capacity is, I'll write it at the bottom a little bit, joules per kilogram per degree Celsius. And this is your final answer. Okay, so next. The experiment is repeated by increasing the mass of the liquid. What will happen to the gradient of the graph K? If you're like, oh my god, I don't know how to figure this out, what you can do is refer to what you've counted here, which is this. I'm going to scribble it at the side here as a reference. You don't have to do this in your actual paper. I'm just going to do this in purple. K equals P over Cm. I'm going to use this to show you how to figure this out. So you got to figure out, okay, if the mass increases, how does K change? And you can see that they're inversely proportional, which means that K decreases. And that's how you figure it out. You don't have to justify the answer. You just need to figure it out. Okay. Now, usually in paper 3, either question 1 or 2, they always ask you for one precaution. Now, there are a lot of precautions that you can use, but some of them are very specific to certain experiments. So if you don't know what precaution to write, just pick one of these 2 which I'm going to share with you. And these precautions can be used for any experiment because they're true for all cases. The first precaution you can write is ensure the eye is perpendicular. Keyword is perpendicular. Make sure you don't write, parallel or something of the sort. Perpendicular to the scale to avoid, something fell, to avoid parallax error. Okay. You must write the entire sentence. If you just write ensure eye is perpendicular to the scale, or if you just wrote avoid parallax error, it won't be accepted. You need to write the how and the why. So that's the first one that you can go with. The second one you can write is repeat the experiment to obtain the average value. So when you think about it, yeah, these 2 precautions can be used for any experiment, right? Because no matter what reading you take, you must make sure that you don't have parallax error to get the accurate value. And of course, in order to try to minimize random error, it will be a good idea to repeat the experiment to obtain the average value. So if you're ever stuck and you don't know what precaution to use, just pick one of these 2. But remember, write the sentence in whole. And that's the end of question 2, which also brings us to the end of this video. So in my next video, I will discuss with you the format for answering section B in paper 3, whether you're answering question 3 or question 4. And also give you a hint to figure out if you don't know the answer, how do we get the answer? Thank you for watching. I hope you found this helpful and educational. Please don't forget to click like and subscribe. Thank you for watching and have a great week ahead.